Hi everyone, I am going to discuss with you an important topic, resistors. So when we consider resistors, we will see these areas here. So what are the resistors, then what are the types of the resistors available, and then different color codes of the resistors and how to calculate the resistance value, and then what are the types of combinations of the resistors and how to calculate the equivalent resistance of those resistors. So when we consider the first topic, so we will see what are the resistors. So resistors, when you hear the name, so it is kind of a barrier for the flow of the current. So we can use the resistors when we need to reduce the electric current, especially in some circuits. If there is a big current flow, the circuit may be damaged in some electrical instrument. So in that case, we have to use these resistors. So resistors are categorized into three main types here. So that's why we are putting here types of the resistors. So when we consider the three different types, we can found. So these are the types can be found. One is fixed value resistors, fixed value, then variable resistors, variable, then light dependent resistors. So when we consider the first one, fixed value, so fixed value means value is fixed. So simply we can't change the value of the resistor, and that will be applied into the instrument, and then that cannot be changed. It will be fixed, and the resistance is a fixed value. So fixed value resistors. Then the second one is variable resistors. Variable resistors means we can change the resistance. So example, in some volume controllers, especially for televisions, radios, volume controllers are used. So this is one example for the variable resistors. I think you have heard about the rheostat, so that is also same. Then when we consider the third type, light dependent resistors, that means when the light falls, the resistance will be usually reduced. So we are using these things, especially in street lamps. You can see in the evening it will be automatically switch on. So how it automatically switch on? There are light dependent resistors. When the resistance value is reducing, the light intensity is reducing, the resistance will be going up and switch on the other circuit and switch on the light in the evening. So that will be discussed in future sessions, and here we are going to talk about different color codes of the circuits, and how color with the color how to calculate the value of the resistor, right? So before that, I will show you what are the different symbols for these resistors. So if we consider fixed value resistor, the symbol will be like this, or else you can see like this. And then for the variable, this is a fixed value variable resistor, it will be like this, or else like this. And for the light dependent resistor, or called as LDR, you may heard about that. So LDR, it's like this. It's like this, or else sometimes you can see like this. So these are the basic symbols that we use for the three types of resistors. So then we will go through the things that we plan to do, how to find the resistance in a resistor by using different color code systems. So I will draw a bigger image. There are three colors here, and with a little bit bigger gap, a tolerance value line is there. So this is called tens place, this is called ones place, and here you will be getting the power of the 10th power of the color, right? So we will see how to find the answer for a specific question related to this example. You think I will just put this as brown, this as black, and this as red, and this will be gold. This is called tolerance line. So here how we do this question, initially you want to take brown color. So brown color, here they mention number 1, so you put number 1. Then second color is black, 0, so you will put that number also. For number 1, brown, number 1, you put number 1, then black, you put 0. Then the third line is the specific line, you will put the 10th power of that number. So here it's red, so for red it's 2, so therefore 10 to the power 2 is 100, so you multiply this by 100, therefore the answer will be 1000 ohm. 1000 ohm is the value of the resistor. But there is a thing called tolerance line. So what is tolerance line? So this value will be increased or reduced. You know, machinery, when we produce these resistors, we can't exactly say this should be the resistance. So that may be vary, it depends. So therefore we are giving a range of the resistance. The resistance will be in between these two. That's why we are having this kind of a tolerance value. So so here 1000. So what we are going to do, you have to multiply this 1000 by for gold it said 5%. It will be also given to you. You can take it by books. So it will be 5%. So it's like this. Then you will be getting as 50. So then what you want to do, you have to subtract 50 and getting one value 950 ohms, and adding that value and get the value that is 1050 ohm. So therefore we can state as the range 950 to 1050 ohm as the resistance value range. So this is how we can do a question easier with the different color codes. Then let's see our final objective, that is how to find different equivalent resistors when they have different combinations. So we will see that by using some circuits. So when you consider the combinations, mainly there are two types of combinations. One is series combination. The other one is parallel combination, right? Series combination and parallel combination. So when we consider the series combination, we will see first series combination and how to do the question easily. So we will see if resistance one is like this, the other one is like this, R2, and if the circuit is like this, you think this is 12 volt. I am not giving here the resistance values, but equivalent resistance can be found by R equal R1 plus R2. So this is the equivalent resistance. So here in this case, if you think this is 3 ohm, this is 3 ohm, then equivalent resistance is 6 ohm. It's just simple, right? So why I have given this. If they ask, if you getting question, here will be a ammeter. If they ask how to find what is the electric current flowing through this, then you can put according to the Ohm's law. According to Ohm's law, you know, V equals IR. According to Ohm's law, V equals IR. Then you can put I, you don't know, R you found 6, V you found 12, it's there. Then I will be 2 amperes. So then here the answer will be 2 amperes. So it's easier to find answers for these questions, right? Okay. So when we consider this question, it's like this. Then we will see if someone asks a different combination. So I talk about the series combination. Then the next type is parallel. So we will see a parallel connection. So if it is parallel connection, it's like this: R1, R2, and here is the 12 volt again. This is the cell, right? So when we consider this connection, you know, it's simple. How to find the equivalent resistance? 1 over R. So this is the equivalent resistance, equal 1 over R1 plus 1 over R2. So this is the equation that you want to put. So here, if you think this is 3 ohm, this is 6 ohm, then how to find it? 1 over R equal 1 over 3 plus 1 over 6, then you will get 1 over R equal like this. So R will be when you take the opposite side, 2 ohms will be the equivalent resistance. For the parallel connections, I will give you some exactly quick method, but that's only for MCQs. But please only use these methods for the structured essay type and also the essay type questions. But if you get an MCQ question, you can use this quick method. We will see what we can follow for this. In that case, so what we can use to find the equivalent resistance, you can use this equation directly. Equivalent resistance equal R1 into R2 division R1 plus R2. From your mind you can do this. Simply, quickly you can get the answer. So you will see how to do that. Example from your mind, how to do it. So this is 3, this is 6. So then 3 into 6 is how much? 18. 6 plus 3 is 9. So exactly, no need to put the units. So 10 division 9, then you will get the answer 2 ohms. So it's a quick method, I didn't put the units, right? So you can use this method, then directly you will get the answer here. So previously you put the all the equations and get the answer, but similarly, so this is the same as earlier one, but we can't use this for the theory essay type questions or structured essay, but you can use this method for the MCQs. So I think you understood. So you can use multiplication, division, addition of the resistors, right? So finally I will tell you, now you got how much? So 2 ohms. When you put multiplication, division, addition, you will get 2 ohms. Then you can find what is the electric current flowing through this circuit. So it is V equals IR V12, I don't know, R is 2. Then you will get the answer 6 amperes. 6 amperes is the answer. Then sometimes in some cases they are asking to find what is the current flowing here only. So you think example here they will put an ammeter. So in this case how to find the current flowing through this circuit only. So here 6 amperes flowing through this, 6 amperes. Usually here the proportion of this is 3:6, that means 1:2. So total is 3. So proportion again, proportion is 3:6, or a simple proportion 1:2. So that means and larger proportion of the electric current will be traveled through this circuit as it has the less resistance. If the resistance is less, current flow is high, you know simply. So therefore how you can divide this, you have to multiply this 6 by 1/3 and 6 by 2/3, because simple proportion is 1:2. So that means one third will be traveled from this side and 2/3 will be traveled from this side. So simply you can get the answers for this as 2 amperes from this way, yes, and 4 amperes from this path. Clear? So you can find it like that. So that is the easier method to find proportion of the that means quarter of the electric current. So I have discussed about different resistors today and how to find the different color codes and how to find the resistance value by using different color codes, and also finally I have discussed different combinations, and sometimes there may be connections like this. So as I am completing the presentation, I will give you one example of a little bit complex situation that students face commonly. So most of the students make this incorrectly. So example, it's like this. So if a student get a question like this, right? Yes, okay. So you think you will get a question like this. So in this case, some students think these two are parallel and these two are parallel, because they are thinking a question like they are doing an art class or else a maths class. So because you can see this is parallel, but exactly when you consider the connections, you can see this part is seriously connected, right? This is seriously connected. So therefore to here even you can see parallel like this, it's not parallel. Don't mix up with the questions. So here to here this part is series, here to here this part is series. That means 4 and 2 are series, then 2 and 1 are series separately. Then you collect these two together and then you can find. So if I replace this by 2 plus 1, 3 ohm, you can replace like this. Then you can replace this by 4 plus 2, 6. Okay, 6, right? So as I did earlier, so if it is parallel, you can put, if it's a essay type question, 1 over r equal 1 over r1 plus 1 over r2 and find the answer as I did earlier, or else if it is an